Hello class, this is Mr. Hart, and in this podcast we want to start our unit on circuits. And we've talked previously about electricity and magnetism, a little bit about electromagnetism, and those are all great principles and all, but when we want to get to applications of those things, okay, one of the most major inventions has been being able to direct electricity through a pathway that we choose, and that's exactly what a circuit is. It's directing electricity in a certain way, okay? And so if we look at the definition of a circuit, okay, it's basically just a metallic pathway for electrons to flow. We basically set up wires and things like that so we can direct electricity where we want it to go. And you already know all the great things we've been able to make with circuits, computers, tablets, phones, any type of electronic device really has a circuit built into it. We use that electricity in a useful way that runs programs and does things like that, and that's why they're so useful. But it all started with the invention of a circuit, being able to direct it the way we want it to, direct the electricity the way we want it to. Okay, and so if you think about a circuit, there's four things that any circuit requires. Okay, and they're these four things. So first of all, it needs a closed loop. Okay, basically it has a specific way that the electrons are going to flow through it, right? And again, it has to be closed, meaning you end up where you started, right? Because electrons just can't get to the end of a wire and stay there, right? Otherwise, you'd get electricity building up at the end of the wire and nothing would happen, right? So they have to be able to flow through a closed loop, okay? And that loop can lead them through all different types of electronic devices and stuff, but it has to start where it ended, okay? And then you need some type of power source, whether that's a battery or a DC power source or a wall outlet or something like that. Okay, then you need the carrier, or the wires, basically the metallic wires that put the electrons through, and then you need some type of load, okay, like a light bulb, a resistor, a computer, anything that basically will use the electrons in some way. Okay, so you have those four components, and then you have a circuit. Okay, easy as that. So we'll get more into circuit design in other videos and other lessons. But let's just look at the basic components of a circuit, okay? And again, obviously we're not going to do the industrial circuits where they use like the green wafer boards that have the circuit etched into the board, right? That's far too expensive to do in this class. So we're just going to go with the basic setups of circuits, okay? And so right here is just kind of a example of what a circuit board looks like for this class. You got the breadboard. You got LED lights, okay, little LED lights that we can use, the metallic wires, and what we call the resistors, okay. And so in another video, we'll go more into how we set up the breadboard and all that stuff to make it work, okay, and how we build these circuits. But for this video, we need to understand the most important component of circuits in this class, and that's these little resistors right here, okay. I know they don't look like much, okay, but these are very fundamental to how a circuit works, okay. And so if we look at resistors, basically all they are is a metal wire that's going through, okay, and it goes through this little device, and on the other end of the wire, it slows down the current, basically, okay. It resists the flow of electrons. And you would say, well, why is that useful? Why would you want to slow down the electrons? Wouldn't that make it harder for the circuit to run? Well, keep in mind you don't want the electrons to move too fast, because if they move too fast, then you have what's called a short circuit, right? Electronics blow. If electricity is moving too fast, it can cause things to break. And so resistors are a very important part of designing any type of electronic, because you want to be able to have the electronic run for a long time without it blowing up, basically, right? So it's actually very important to be able to slow down the electrons in such a way that it has a consistent flow that won't destroy or damage the device. Okay, so let's see how this resistor works. Okay, and when we're trying to describe resistors, okay, we're going to think about the resistor in terms of a couple of definitions. Okay, so here are three words that you're going to want to be able to understand and know for resistors. Okay, so obviously the current. Okay, you probably have heard this word before, but current is the amount of electrons flowing through an area, and specifically through a circuit. Okay, and so again, you don't want that moving too fast, because otherwise it could damage components or things like that, right? So you want the current to be a little bit slower than, or actually want a lot slower than it would just be with a wire, right? So you have to put in some resistance, okay? And that is basically the amount that a device or a wire restrains electrical flow, okay? So it's going to slow down the electrons so they can't go as fast through the wire so that you can use them on devices without having them short circuit, okay? And so the resistance is how much it does it, and the resistor is the component that's designed with the specific resistance. So this little guy right here is designed to resist a certain amount of electron flow. Okay, and we'll get to in a second how we describe that. Okay, but make sure you understand those three words. Okay, so the resistor has a certain resistance that limits the current. Okay. All right, so let's look at how these things are designed. How do you make something that slows down electrons? Okay, and if you look at the inside of a resistor, it kind of looks like this. Okay, so you can kind of see there's these different little bands on the edge of a resistor. Okay, these different colors. They tell you how much resistance is inside this resistor, but in reality, all it is just a wire, but it's looped around on the outside of the resistor. Okay, and things with very low resistance, okay, that let a lot of electricity through, only have a couple of loops, whereas something with very high resistance has a lot of loops inside of it. Okay, and so what happens is those loops generate kind of a magnetic field, right? Going back to electromagnetism a little bit, they generate a little bit of a magnetic field, which causes the electrons to slow down as they're going through. It also generates a lot of heat because the electrons have to go through the wires more quickly in that small area, which generates a lot of heat in that area. Okay, so resistors can get pretty hot if you are not careful. Okay, but there you go. It just kind of loops around on the outside. Okay, and basically how many loops you have inside of the resistor determines how much it resists the flow, how slow it goes. Okay, and so we want to be able to determine this resistance, okay, for any resistor. Okay, and just so you know, the resistance is given this special symbol. Okay, so if you ever see this symbol right here, which is capital omega, by the way, that is the resistance value. Okay, and so you'll see that at the end of a lot of resistors. Their values has that omega symbol. That's just telling you the resistance of the circuit or the resistor. Okay, all right, so let's go into how we actually read what a resistor value is. Okay, and it comes from this table right here. Okay, so they're given four bands on the resistor. Okay, 4 little bands of different colors, and those colors range from everything from black all the way down to white. So brown, red, orange, yellow, green, blue, purple, gray, and white all have different meanings on the resistor. Okay, so what we have to do is we read the 4 bands and they tell us about the resistance. So for example, let's just do this resistor on the screen right now. So we got red, black, red, gold. So if we're trying to read this guy, okay, what we're going to do is we're going to read that first band, which is red. So we look and we'll say, okay, that is the number 2. So our first number is 2. Okay, then we look at the next band, which is black. So that's equivalent to 0. So our second number or digit is 0. Okay, then we read the multiplier, which says is red, and red in this case means times 100. Okay, so if we put that there, okay, then we have 20 times 100, so this resistor's value is 2,000. Okay, this is a 2,000, and then we put the capital omega, and this is what we call ohms, 2,000 ohms of resistance. Okay, this is a 2,000 ohm resistor. Okay, so we read the first number, read the second number, and times it by the multiplier. Okay, now this number right here just tells us how accurate that measurement is. Some resistors have really good values and are very precise. Some are very relaxed and are just kind of around that area. Okay, so we call that the tolerance. So this is a gold band, so that means it's within 5% tolerance, okay, meaning it's within 5% of that value. So it could be as high as 2,000 and 100, or as low as 2,000 or as a 1,900, right? But don't worry too much about the tolerance. It's just saying how accurate that resistance is, okay? So like a band that's brown or red is very close to that measurement. Something that's gold or silver is very relaxed. It's around that area, okay? But don't worry too much about the tolerance. Just focus on getting the resistor value, okay? All right, so let's do this guy, okay, right here. So you see this resistor right here, okay? Or I guess probably should flip it around for you guys. Okay, so we see this resistor value right here. And so what we're going to say is, okay, all right, so we look and we see, so that first band is brown. Okay, so if we went to our little table, okay, well, brown is 1. So we're going to start with 1. Then the next two bands are black. Okay, so that means black is 0, and the multiplier is 1. Okay, so in this case, this resistor is just 10 ohms. Okay, and there we go. So this is a very small resistance value with a lot of electricity through. Okay, or let the current be a lot higher. Okay, let's just do one more for practice. See if you can do this one before I tell you how to do it. Okay, so we got, it looks like green, blue, and brown. Okay, green, blue, and brown. So if we're looking at that resistor, we say, okay, well, green is going to be 5. Blue is going to be 6. And then brown is going to be times 10. Okay? So 56 times 10 tells us that this is a 560, ohm resistor. Okay? All right, so hopefully this makes sense, right? This ability to kind of read the code of the resistor, okay, and be able to determine how much value you have. Okay, and if you think about it, this is pretty smart, because some of you may be wondering, well, why don't they just like print the number on the resistor? Wouldn't it be easier just to say, well, this is a 56 or 560 ohm resistor, okay? And you may say, well, that makes sense when the resistor is this big, okay? But keep in mind, there's some pretty small resistors, and especially when they get down to like computer level, and now they don't even use this same system, okay? But the color bands are very helpful because even at small scales, you can still see the colors, even if you can't read the print or read the numbers, okay? And so this is why they did resistors this way, because they could see that the resistors were going to get smaller and smaller and smaller, and so they used colors instead of actual numbers so that you could determine the resistance even if you couldn't read the small text, okay? And it's also a really cool system because you can represent any number because of this multiplier, okay? Because you can get up to, millions of ohms all the way down to 1/10 of an ohm or 100th of an ohm, right? So very clever way to make these resistors in a way that you could read them even if the text was too small to read, okay? So there you go. That's how you read a resistor code. Okay, so in class, I'll hand you out a resistor code sheet that kind of looks like this, okay, that you can reference for any resistors that you use in class, okay. Also, we'll have the 5-band code information as well. You don't see 5-band codes as often, but sometimes they are the case, and that just has 3 digits and then the multiplier, but it works the exact same. So make sure you get that reference sheet sometime down the line. You can print one off at home, but you need to have a color printer. I'll have color copies in class if you need one. Okay, so just come see me if you need a reference sheet. Okay, but other than that, just make sure you do the homework assignment. You'll have 2 sides of it where you're identifying what the resistance values are for different resistors. Okay, and we're just using that same color coding. Okay, that color code for resistor values. Okay, but hopefully that made sense. Let me know if you have any questions, and thank you for watching.